A European weather satellite has reached its transfer orbit and is confirmed healthy after an Ariane 6 launch. This is Fascinating Frontiers, episode 176. The MTG-I-2 satellite acquired signal shortly after separation, and all systems checked out nominal. It will join two earlier spacecraft to give forecasters continuous high-resolution views of Europe and Africa. The third-generation instruments are designed to deliver sharper imagery and faster updates than the previous Meteosat series. Engineers will now perform a series of orbit-raising burns over the coming weeks. Earlier warnings of severe storms are the main operational goal once the satellite reaches its final geostationary slot. The MTG-I-2 satellite's successful signal acquisition marks the final piece of Europe's third-generation weather constellation, now moving into its operational orbit. Once stationed, the spacecraft will supply continuous infrared imagery and lightning detection over Europe and Africa at higher resolution than earlier satellites. Forecasters expect earlier and more precise severe weather alerts as a direct result. The constellation's staggered launches have already demonstrated incremental improvements in data latency. Next, teams will complete the orbit-raising sequence and begin on-orbit checkout of the advanced instruments. From one European mission securing its place in orbit, we turn to hardware returning from space for detailed study. The Starship upper stage was loaded onto a semi-submersible ship in the Indian Ocean after more than a month afloat. Recovery teams worked through challenging sea conditions to secure the hardware. Data from the flight and the recovered heat shield will guide design changes on upcoming vehicles. The ship is expected to arrive at Starbase in several months. Engineers plan to examine the structure in detail once it reaches the Texas facility. This latest recovery continues the steady progress on Starship hardware return that we have followed since episode 174. While one Starship vehicle heads back across the ocean, another has already yielded fresh samples closer to shore. Teams spent several days examining the vehicle in waters off Christmas Island. Samples of the heat shield tiles were taken for laboratory analysis. The data will show how recent material improvements performed during re-entry. Insights from this inspection are already feeding into upgrades planned for future Starship vehicles. The effort marks the first detailed post-flight examination of a ship after an extended ocean recovery. From hardware surviving re-entry, we move to a world that may not survive its star. Astronomers identified a planet with a substantial water inventory orbiting close to its host star. The world's orbit is decaying, raising the possibility that the star will eventually consume it. Observations suggest the planet formed farther out before migrating inward. Continued monitoring will track changes in the orbital period over the next few years. The case offers a rare look at a planet in the final stages of its life. While one planet faces engulfment, researchers are asking how easily Earth microbes could linger on another world. Deep craters and permanently shadowed regions at the Moon's poles create cold traps that might allow Earth microbes to persist. Forward contamination protocols aim to prevent any terrestrial organisms from reaching potential native life. Radiation and temperature swings normally destroy hitchhiking microbes, yet polar topography may provide shelter. Researchers are modeling how long such organisms could remain viable in these environments. The findings will inform landing site choices and sterilization standards for future missions. From contamination risks on the Moon, we look at the tight timetable planets face while forming. Young stars drive powerful winds that can strip away the gas in protoplanetary disks within a few million years. Gas giant cores must accrete their envelopes before this reservoir vanishes. Observations show that the window for giant planet formation is therefore tightly constrained. Disks around more active stars lose their gas even faster, shortening the available time. The process explains why many observed systems contain only smaller rocky worlds. A typical protoplanetary disk stretches several times the distance from the Sun to Neptune, yet the gas it contains can vanish in as little as 3 million years under the push of a young star's intense wind. Picture a city-sized reservoir of construction material being steadily blown away by a hurricane that never stops. Inside the disk, dust grains collide and stick gradually, building rocky cores that then pull in surrounding gas if they reach roughly 10 Earth masses before the supply disappears. The faster the central star spins and flares, the shorter that window becomes, which is why many observed systems end up with only small rocky worlds instead of gas giants. We still do not know exactly why some disks lose their gas in under 2 million years, while others linger for 5 or 6, even around stars of similar mass and age. From studying the sun's atmosphere, we shift to watching Earth's own shadow cross the moon. Aircraft flew beneath the path of the August 12th total solar eclipse across Europe to study the sun's outer atmosphere. The corona remains far hotter than the visible surface, a long-standing puzzle. Coordinated measurements from multiple aircraft provided continuous views of the same coronal structures. Scientists hope the data will clarify the heating mechanisms at work. Additional eclipse flights are planned for future events. The moon will pass through Earth's shadow in a deep partial eclipse visible across much of the Western Hemisphere. Observers can watch the northern portion of the lunar disk darken for several hours. The event closes a busy August that already included a total solar eclipse and the Perseid meteor shower. No special equipment is required beyond clear skies and patience. Timing predictions are available from major astronomy organizations. Satellite views reveal how the Congaree River continually reshapes its floodplain through meanders and oxbow lakes. The resulting wetlands support tall hardwood forests that are rare in the southeastern United States. Seasonal flooding deposits nutrients that sustain the ecosystem. The imagery helps track long-term changes in river course and forest health. Similar floodplain dynamics are studied on other planets with liquid surfaces. Engineers describe the challenges of radiation tolerance and power efficiency in these systems. Golden Dome and Artemis missions are cited as drivers for higher data rates. The conversation highlights work with the Space Development Agency on large constellations. Listeners learn how commercial components are adapted for orbital use. Staff at NASA's Jet Propulsion Laboratory begin each shift by checking telemetry from the active rovers. The control room coordinates commanding data downlink and anomaly response. Morning briefings review overnight events and set the day's science priorities. The process has run continuously since the first rover landed more than 2 decades ago. Newer missions share the same facility and procedures. New measurements show a dwarf galaxy merged with the young Milky Way 1.8 billion years earlier than previous estimates. The evidence comes from stellar motions and chemical abundances captured by the telescope. The finding revises models of how the galaxy's halo assembled. Astronomers will now search for additional ancient merger signatures in other datasets. The work extends the known formation history of our galaxy. The upcoming observatory is expected to discover large numbers of exoplanets through microlensing and direct imaging. Its wide-field infrared camera will monitor millions of stars simultaneously. Mission planners anticipate the first data releases within months of reaching orbit. The telescope's sensitivity will complement existing surveys that focus on closer-in worlds. Launch remains scheduled for the end of the month. Faculty and students contributed to instrument calibration and science planning for the Nancy Grace Roman Space Telescope. Their work focuses on weak lensing measurements that will map dark matter distributions. The team is finalizing observation strategies ahead of the August 30th launch. Data from the mission will be publicly available through the Mikulski Archive. Training the next generation of analysts is a parallel goal of the university effort. The funding supports development of new European launch vehicles beyond the established Ariane and Vega families. Contracts target companies still scaling prototypes rather than only legacy providers. The goal is a broader industrial base capable of meeting future institutional and commercial demand. Milestones include engine tests and first-stage recoveries. First orbital attempts under the program are expected within 5 years. Space News keeps revealing how narrow the windows for planet formation and satellite operations really are. Keep an eye on the next set of Starship heat shield tests, scheduled after this recovery arrives in Texas. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NARA Network. Links in the show notes. Quick tip from the network. Try the Do Positive Pod next. Good news in science and tech, plus one concrete action you can take. Every NARA Network show is free at naranetwork.com. Want the written briefing with source links? Each show keeps a summaries page on naranetwork.com, scannable, dated, and free. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.